Saxon Advanced Math Lesson 52.b. This is arguments and trig equations. And we're going to jump right into this with an example. And I'm going to change the example the book used just a little bit to make it a little bit smaller of a step for some people. Of course, I always suggest that you follow along in the book as far as looking over the example problems as well. They are very clear in the book. I just went ahead and broke this down one step further to bridge that gap between what we already know and where we're going to. They want us to find the tangent of 3 theta minus 1 equals 0. Now, this is what's new. This little 3 sitting in here. If they just said tangent of theta minus 1, we feel pretty good about that and we know what to do. But this one this has that 3 theta in here. So we're going to go ahead and treat it like it's not there to begin with. We do have a range of values. They said 0 is the smallest value for theta, and 360, less than 360 is the largest value. So this is the range of values that theta can be. Next thing I'm going to do is put in this 1 to the right hand side. I'm adding 1 to both sides, and I can do this without violating my argument because the 1 is being added to the outside of whatever the tangent of 3 theta is. If there was parentheses on this, and there were a set of parentheses sitting here like this, the tangent of 3 theta minus 1, I couldn't do that. I would have to just leave it like it is and solve it in another method. But the tangent of 3 theta is a separate term than negative 1, and I therefore can move the negative 1 to this side by adding it. When I do so, I get the tangent of 3 theta equals 1. This is where I am going to diverge just a little bit from the book method that's being shown, and we'll catch back up to that book method in just a minute. If I'm going to go ahead and say I'm going to let x be equal to 3 theta, and the reason why I'm doing that is I'm encapsulating that 3 theta into a value that makes more sense in my head at least, and I'm saying if there was a value of x, because I can say x is anything, I'm going to say x is 3 theta, and then I'm going to substitute that in and get tangent of theta equals 1. At this point, most of you should be able to look at this and say, hey, I know what to do with the tangent of theta equals 1, or tangent of x equals 1. Because I can solve that out by using my triangles, right, and graphing this. So I look at this and say the tangent of what value is equal to 1. Well, in the first quadrant, that would give me opposite over adjacent. That's a 1 over 1, and that's a 45. There's another quadrant that works. All students take calculus. So if I want a positive tangent, it's positive in the first and the third quadrant. If it's positive in the third quadrant, and I took the same triangle and drew it there, which I did, this would be a back one and a down one, which remember the negative over negative is a positive. That's why it works. That's why the tangent is positive in the third quadrant. That would be a 45-degree angle here. 180 plus my 45 gives me my 225. At this point, I say x is 45 or 225, and my range is between 0 and 360. So I already have my answers. My answers are going to be 45 and 225. That's what we already know how to do. At this point, we're going to go back and resubstitute this back in, or put this back in and say, wait a minute, what was x? X is 3 theta, so I plug that in. 3 theta equals 45. X was also 3 theta for this one. 3 theta equals 225. Now I divide both sides by 3 and get theta. The actual value for theta is 15 and 75. Because if I put this back in, I said 15 times 3, right? That would give me my 45. The tangent of 45 is 1. 1 minus 1 is 0. However, I can do that with a 225 as well, right? Because 75, put back in here, 3 times 75, 225. Tangent of 225 is still 1. 1 minus 1 is 0. And we should be done. But we're not, and here's why. I have this range that's saying theta can be between 0 and 360. But whatever I'm putting in for theta is being multiplied by 3. So really it's the tangent of x minus 1. So that means this 45 is not really a 45, it's only a 15. 15 is being put in here. 15 times 3 is 45. And that's where I'm getting at. So I have all these other values that theta can be and still be between 0 and 360. So how do I find out how many values my theta can be? Well, it's going to triple my theta. It's going to triple my range. So I'm going to say 3 times 0, which is 0, and 3 times 360, which is 1080. I know that whatever I'm actually putting in for theta can be between 0 and 1080. Because really, if this was x, I'm saying 1/3 of x, right? So I'm actually tripling my range by saying a value of 3. So I need to go around the circle that many more times. So I went ahead and put down my 45 and my 225 because I know that's what x is. And I said that's my first quadrant and my third quadrant. But you realize that I'm now not just limited to 360, I'm limited to 1080. So I go ahead and say 45 plus my 360 is 405, plus 360 is 765, plus 360 is 1125. And I stop there and I cross the 1125 out because 1125 is greater than 1080 and it no longer works. I go to my 225, add 360, get 585. Add 360, get 945. Add 360, 1305. Ooh, I got another problem. That's too big. So I know that these values are the values that work. Then I go ahead and just divide that 3 back out of them, right? Because that was where that 3 came from. So I say 45 divided by 3. Actually, theta can be 15, right? It can be 75. We already had those two. 405 divided by 3 is 135. Is 135 still fit in my range? Sure does. And if I put 135 in for this, it still works. And so I have to use that one as well. 405, tangent of 405 is still going to be 1 minus 1 is still 0 and still is my range of theta values, right? My theta values are still allowed. So I'm going to go ahead and put in 405 over 3, 135. 585 divided by 3, 195. 765 divided by 3, 255. 945 divided by 3, 315. And I went ahead and put the 1125 in here just to show you what happens if I did so. 1125 over 3 is 375. This is why it's not allowed, because my range of theta is between 0 and 360, and 375 is greater than 360. So it's not allowed to be in there. This is why I know how far to go. Okay? Now I was able to stop right here because I already knew that 3 times 360 is 1080. So any values greater than 1080 or equal to 1080, that shouldn't be there, I apologize. Any numbers that are equal or not equal to but are greater than or not less than 1080 are not allowed. So I know that these two here, these numbers here, even though they are multiples of going around the circle, right, it would work, but they don't work within the range defined. So this is where we get into, like I said in the previous lesson, there are multiple answers that solve this. Any of these values, 15, 75, 135, 195, 255, 315, and 375 is not, and 315, they all work if I put them in. And you can always check this with your calculator to make sure your math is right. If on your calculator, you put in 315 times 3, take the tangent of it, you'll equal 1 every single time. And so this allows me to take and expand that range. Now, this is a little bit deeper thinking here. If this number here is expanding these by that multiple, what happens if this number was a fraction? The answer to that was it would limit these by that much. If this was theta over 2 instead of 3 theta for the same exact problem, then I would take this value over 2 and this value over 2, and I'd say my values for theta are only between, actually putting in there, are between 0 and 180, not 0 and 360. And this one, but this one being 3, is multiplying these by this. So you can remember it either way you want, or you can just keep trying by adding 360 to each one of your values that do work. But keep in mind, there isn't a set number of values that you're looking for in an answer. For instance, I say, well, the root of 9 is 3 or negative 3, and so I'm always looking for 2 values. It's not like that. Because I'm looking at it saying how many are in the original, and then I'm looking at the range, right? So there was 2 in the original answer, and then I extended that because I substituted it back in. The book didn't use the x, and that's fine, because they realized that tangent of 3 theta equals 1, and whatever the tangent is had to equal 45. Then they divided it by 3 to get to 15, and that works just as well. I only put in the x, and I continue to put in the x on my work because it keeps it straight in my head as far as knowing that the tangent of x equals 1 is a lot easier problem for me to solve. And once I get my originals, then I can worry about what was actually in there for that theta blank. So, and as these get more complex, that little trick will help you out.